Hello everyone, welcome to the session ArcGIS Runtime SDK for Android Building Apps. I'm Ramachintapalli, Senior Product Engineer in the Android team, and I'm joined by my colleague Priyanka Rupani. So here is the agenda for today's session. We'll give you an introduction to the SDK, where to get the resources from, how to get started in building your applications. And then we'll talk about some of the developer patterns that we follow when we build the SDK. And then we'll give you a functional overview of the SDK so that you have a clear idea of what are the classes that are available and things that you could do with the SDK. And then we'll talk about some of the general themes of where you could categorize your app into and build specific applications for those. And finally, we'll talk about some of the new things that are coming into the SDK. So let's get started. So what do we mean by building ArcGIS Android apps? So if you're looking to build native Android applications for your mobile or tablet devices, then ArcGIS Runtime SDK would be a best place to start with. Esri provides a lot of in-house applications like Collector, Navigator, Workforce. All these apps are built on top of ArcGIS Runtime SDK. And if you want to build something similar that would cater to your organization, then this would be a good place to start with. So how do we get started? You need to sign up with a free developers account where you could register your apps. You can just go to developers.arcgis.com and sign up for a free account there. You will get some base map and geocode transactions for free when you sign up. And then you need an IDE to develop. So you go to developer.android.com and download the Android Studio IDE, which is the default recommended IDE for Android development. And then you need to get the Runtime SDK, and we provide that in two ways. One, adding it as a dependency in your Gradle, or go to the developers.arcgis.com and download the SDK locally, and later you could add that as a dependency from your local file. So the most popular way of adding the SDK is adding as a dependency in your Gradle. Again, especially if you're in a connected scenario, this is the most preferred way. We make the SDK available through a Maven repository, which is hosted on a bin tray. And the way you could add the Maven repository to your project's build.gradle file is to include the repositories there. And then you add the SDK as a dependency in your apps build.gradle module file. As you can see how we added here. So once you add the SDK as a dependency in your Gradle file, the project automatically downloads the SDK for you and builds your app. So once you have the SDK ready, you can build the app either in Kotlin or in Java. We support both, although Kotlin has been the more favored one from Google in the recent times. So we still support both Kotlin and Java when we do provide samples for both of them. So depending on the comfort level of your developers, you could choose the language of development for your apps. That said, let's see our first demo from Priyanka, how to build a simple mapping application. I'll hand it over to Priyanka.
Hi, I'm Priyanka. So I will take you through a quick demonstration of the first map app. So let's switch to Android Studio. So this is the build.gradle file of the project. This project is a demo app named demo app, and it's a empty Android Studio project, and it is Kotlin based. So if you go to the build.gradle file of the project, you see you need to add the Esri bin tray URL, Maven URL here, which basically hosts the SDK resources. Um, and then you will move to the build.gradle file of your app and go ahead and add the SDK dependency here. If you see, this is the package name, and this is the product name and the version that you would like to use. And as you've seen here, I have also added a toolkit dependency, which would give you access to features like the augmented reality, bookmarks, compass, and scale bar. So moving on to the layout file, as you see here, I've added a map view component from ArcGIS Runtime to be able to use that in our app. If you go to the main activity here, you see in the on create, I am setting the content view of the layout file that we just saw, and also creating an ArcGIS map with which is taking a base map type of imagery with labels, a latitude, longitude, and level of detail information. Then you're going to set this map to be displayed in the layouts map view. Now, if you try to run this application, it's running in an emulator, and you see the map which we had defined is being displayed here. So this is as simple as that. It's just in the project build.gradle, you need to give the Maven URL of the Esri bin tray, which hosts the SDK resources, and then add the SDK dependency. And if you're using any of the toolkit resources features, you need to add the toolkit dependency, and then define your layout and the main.activity, where you define the map and set it to the map view. So I will hand over to Rama to go over SDK resources.
Okay, now that we have seen our first mapping application, let's see some of the resources available to take your app to the next level. You can go to the developers.rgs.com, where we provide an guide doc which gives you a conceptual explanation of some of the concepts in the SDK. And we also provide API reference doc which explains what each class and each method does. And then we also provide details about the samples. And all our sample code is open source and is available on GitHub. We also have a GeoNet community where any of the developers could participate, post questions, or answer each other's issues. So there is a lot of community activity happening in the GeoNet. So if you have any questions, you can always feel free to go and post there. We also have a sample viewer app that is available in Play Store. So you can go to the Play Store right now and download the sample viewer app, which actually summarizes all the samples in a single app, and then you can actually view the samples as well as the code through them. We also have develops. Develops are more like step-by-step instructions that help you learn the SDK. And then finally, we have open source apps as well. Open source apps are probably the next level of applications which follow good design principles. So they're not as simple as a sample app, but they kind of have an workflow associated with them, and since it also follows some of the best design principles that Android provides, so those are also a good starting place to build your apps. So you can download one of the open source apps and have some of the existing functionality and then build on top of them. Okay, now that we have seen all the resources that are available from the SDK, let's talk about the Android CPU architectures. In Android development, it is important to understand that there are a wide range of devices out there in the market, and the apps that you're building should cater to all those devices. The Runtime SDK for Android supports the ARMv8 64-bit the ARM v7 and x86 32-bit native libraries. And also, it is important to understand the size of your APK. If you by default include the Runtime Android SDK, it would include all the 3 native libraries. So in order to filter them, you can use the ABI filters in your Gradle file, where you can specifically mention which device you are targeting. So this will greatly reduce the size of your APK. And also Play Store recommends uploading multiple APKs that your app can cater to. And to see how to configure this APK splits, you can actually go to developers.android.com and read through how you could upload multiple APKs, so that when users download your app, they get the APK that the device supports. Okay, so with that introduction, let's turn to the developer patterns. I'll hand over it to Priyanka.
Okay, so let's go over the developer patterns. So we will go through different developer patterns used in our API, which will help you build responsive native applications having great performance. These developer patterns are applicable to all other runtime APIs as well. So there are 4 different developer patterns that I'm going to talk about today. The first one is Loadable pattern. Second one is the ListenableFuture pattern. Third one being the ListenableList pattern. Fourth one is the task and job pattern. So let's talk about the loadable pattern. So loadable pattern is a pattern of loading the resource metadata asynchronously. So there are resources that depend on remote services or data set on disks to initialize their state. So resources that are mentioned here, like the layers, maps, scenes, portal items, tasks, and so on. So the loadable pattern helps these resources to initialize their state asynchronously. All these resources implement the loadable interface. So as you see the state transition diagram that is on the right, it represents the stages that a loadable resource goes through. So starting off with not loaded, resource that has not been asked to load its metadata and its state is not initialized yet. From not loaded, the resource can go to loading, that is the process of loading the metadata asynchronously. From loading, it can go 2 ways. The first being it can get loaded, that is the resource successfully loads its metadata and the state is initialized, or it fails to load due to various reasons like the network outage or some operation was cancelled and so on. So in that case, you can retry loading. So in this slide, let's go over the example of a loadable pattern. So as you see here, the loadable interface used on this portal object is initialized using ArcGIS.com. This portal object is initialized using ArcGIS.com. So you call add done loading listener on the portal object, and this code, that is in the override code, it runs in the background. So it checks to see if the portal is loaded or not, and if it is not loaded, you can capture a load error and stop then and there, or you can retry loading. But if the portal is loaded, so if you see here where it's checking for load status to be is equal to loaded, so there you can create a portal item which is a loadable object. So you can call portable the add done loading listener on the portal item, and you can check whether it is loaded or not. Again, if it is loaded, you create ArcGIS map using the portal item, and you set it to map view. Else, if the loading fails, you log the load error and stop then and there, or you can also retry loading, but here we are stopping. So at the end, don't forget to call the load async method on the portal. So as you observe, there is a chaining of loadable. One loadable is called by another and it kicks off that process. So moving on to next slide. Yes, so here as you observe, there is a chaining of loadable. So the 20 lines of code are converted to these 4 lines of code. So the 20 lines of code from the previous slide were converted to these 4 lines of code. So here, when we set map to map view, the map is a loadable object, and set map will call load async on the map. So map is taking a portal item, and portal item is loadable. So load async is called on that, and like so on. Moving on to the next slide, we will go over the ListenableFuture pattern. So the ListenableFuture pattern, it basically simplifies many asynchronous tasks in our API. It executes operations in a background thread. As you can see, the ListenableFuture interface extends the future interface. It's a promise to return a result of a certain type. So let's look at an example on the next slide. So here, as you see, we have an mLocator task. So we will call the geoasync method on it and pass the parameters. It returns a list of geocode result, which is wrapped inside a ListenableFuture. Because ListenableFuture has add done loading listener, we do all this work in the background thread. So dot get on the future is done on the main thread, and hence it is done off the main thread, sorry, hence it is not blocking the main thread. So dot get is put inside a try catch block. In case of error, you can like catch the error. So error like network interference will cause the interrupted exception. So moving on to the next slide, we will go over the ListenableList pattern. So ListenableList pattern is a listenable version of a list. Basically, ListenableList basically extends the regular list. This pattern has listener to know when the list content changes. So as you can see here, the graphic overlay holds the graphics. So when you call get graphics, you are getting a listenable list of graphic. So if you want to add graphic, you would have to first call get graphic and then add graphic. So there is no such thing as a set graphic here. So to add a graphic, you first get the graphic, which gets a listenable list of graphic, and then you add graphic on to that list. So this is the listenable list pattern. So next up is task and job pattern, the last pattern that we'll go through. So tasks are used at many places in our API, and task may potentially return a result or return a job. So there are some tasks like geocoding tasks and routing tasks will return a result, when they are done. Uh, the more longer running tasks like the export classes, sync tasks, offline workflows will return a job instead. That means these long running tasks on which we can use various listeners to check progress and completion. These jobs can be started, paused, resumed, cancelled. So we'll quickly walk through the code in the next slide. So over here, we are creating a task by initializing it to use the required service. And then defining the input parameters for the task. So we are calling async operation method to get the job. Then you start the job like dot start. Um, so so there are two things you can do here now. Once the job is started, you can uh, as you can see here, there is an add progress change listener, so that you can optionally listen for changes to the job status and check the job progress. And also the add job done listener listens to the job completion and gets the result from the operation. So you check for errors in the job, and if it's successful, use those results. um, So yeah, this is about the task and job pattern. So I will hand over to Rama to go over the overview of SDK.
Now that we have seen some of the developer patterns in the SDK, let me take you through the functional overview of the SDK that will give you a better idea on how we think through in organizing the classes within our SDK. The first of the components that are required to build applications are the view components. And in Runtime SDK, map view and scene view comprise the key view components, and both of them inherit from the geo view, which in turn inherits from the Android view group class. We also provide a lot of other view components like the callouts, magnifiers, sketch editors, and some of the toolkit components like scale bar, compass. So to help to create better UI components in your applications. And for these view components like map view and scene view, the data has to come through the model, which is the ArcGIS map and the ArcGIS scene. And as I said, ArcGIS map and ArcGIS scene will be the central component for the data source in the Runtime SDK. So these objects can individually be created through layers and tables, where the layers can be coming from the web services of the ArcGIS platform or any third-party services. So in ArcGIS platform, we have like the ArcGIS tile layer, ArcGIS vector tile layer, raster layer, and many other different types of layers. And the feature services come through as a feature layer, which is backed by a service feature table. Similarly, we have this third-party layers like WMS, WMTS, and other layers. So that's one way of creating the ArcGIS map. Also, since ArcGIS map is the central component toward the ArcGIS platform, you can get the web map get the map as a web map which is hosted on an ArcGIS Online or an ArcGIS Enterprise. Or you could get the same map authored in an ArcGIS desktop platform like a mobile map package or a mobile scene package, and you can create them in runtime. So since the schema behind the map and scene is the same across the platform, it's very easy to interchange and use these components within runtime and other products within our GIS. And we have the other components like tasks, which execute some operations on either map, scene, or layer and give you results which you can use in your applications to make some meaningful results out of that. For example, for search and navigation, you could use the locator task or the route task. And for taking maps offline, like you could use an offline map task or an offline map sync task for syncing things back to the web service. Or you could do some analysis in 3D using line of sight or viewshed. And also we give a comprehensive packages to work with ArcGIS platform, like the portal packages where you could use classes to connect to the portal, access resources, do edits, and completely work with the portal framework. And also we provide all the inbuilt security as well that is required to work with the ArcGIS platform. Similarly, we have our own set of packages to work with utility networks. So that's how like we try to broadly kind of package all our components within the SDK. So that gives you an high level overview of what components we possess and how we model them. So once we have this idea, let's next see through some of the application themes that we can follow and build apps that cater to those themes. And again, these themes are not limited, but you could create your own custom theme application which can have functionality for across multiple themes that we are going to present today. So with that, I'll hand it over to Priyanka, who will show the first theme, which is mapping.
Hi. So I will go through some of the mapping features that are available in our SDK. Some of them include the authentication with your ArcGIS Online or your own portal using OAuth 2. You can use the geocode functionality and the reverse geocode functionality to perform functions like the place search. Also, use the routing service to navigate. Um, I will show um, a brief demo of some of the mapping functionalities. So I have an emulator open here. It has, so this is an ArcGIS Runtime SDK samples app that I downloaded from the Google Play Store. We also have uh, the GitHub repository, which is a public GitHub repository for these samples apps. So you could find all the code and basically helps you get started with building your app using the different features of GIS runtime. So as you see here, these are the different features with different samples. So layers has 28 samples, maps and scene has 17 samples, search and query, utility networks, visualization, AR capabilities too. So just helps you get started with your own app. So today I'm going to showcase, I will start by showcasing the authentication app, uh, which is under cloud and portal, but you can also search using the search bar here. So the authenticate with OAuth app basically uh, authenticates with ArcGIS Online using OAuth 2 to access the private web maps and layers. So this will require you to log into the portal. So once I click on this map, this will you will be asked to for ArcGIS Online login to view the private data, the layers. So I will enter the username and password here, and the password I will enter using this command, and I will sign in. So if you authenticate successfully, the traffic layer as you see here is displayed. Otherwise, if the authentication fails, the map will contain only the public base map layer. So we will go through a little bit of behind the work, that is some code on it. You can also see it here, but I have it open in my Android Studio. I'm sorry. So as you see here, we are creating the OAuth configuration. Basically, you set up an OAuth config with the URL or portal, and also your client ID and redirect URI. Then you're setting up the ArcGIS authentication manager to basically handle all the authentication challenges. So you pass this default authentication challenge handler that you created here in your authentication set authentication challenge handler. So the authentication manager is the one that because of which you see the dialog to enter your username and password on ArcGIS Online. So here you're adding the OAuth configuration to the authentication manager. So this is a very simple code showcasing the authentication manager, the use of authentication manager in the Authenticate with OAuth app. So I will move on to the next sample that I wanted to show, which is a search and query sample, which is a find place sample, which uses the geocode functionality. So okay, so you have the find place sample here. Just a minute. Okay, so as you see here, basically this particular sample uses geocode functionality to search for points of interest around a location or within an extent, as you see here. And let's try to run this sample. So here in the point of interest search view, you will specify the point of interest. Let's enter Starbucks. And here you can enter the location that you want to search. As you're typing, you can see the suggestions that are being displayed. I don't know what happened there, but I'll try to type in again and click search. So when you clicked search, the resulting locations are shown on this map. So when I tap on one of these red pins, which are the resulting locations, it will give me the details about the location in a call out, as you see here. So let's try to see the code for this, which is here. Okay, so how this works is you have a suggest async method, which is hidden somewhere here. Yes, so you have this method, the sample uses this method. It takes in the search text that you gave and the suggest parameters. You use it on the locator task. So basically this is where you get the suggestions while you are typing. And then you have the get categories method here on this line. So this particular method, the suggestions for each text field are restricted using this particular method on suggest parameters. So, and then there is a get display location method, which is used here on, yeah, so on geocode result, like once you get all your geocode result to focus search area, you can use the get display location on it. to get the coordinates for that location, and then you can use that location in the set search area function of the geocode parameters to find the point of interests using the suggest async method that we specified before. So it's a pretty long code here. It's like almost 600 lines of code, which is available publicly for you to go through. It's you have a lot of comments in here for you to understand the code, but we will move on to the next sample, that is the navigation sample. So the navigate route sample, which is under the routing and logistics. So you use the routing service to navigate between 2 points. So let's try to show that. If I click on this sample, it starts auto navigation when you open the app. So now when it's taking this U-turn, you will be able to hear the voice. So this basically stimulates traveling and receives directions from a preset starting point and a preset destination. So if I am moving, panning around this map, I have a recenter button here to return the map view to set the autopan mode back to navigation. So you'll see here. So now we will try to kind of go through a little bit of the code behind this, which is right here. So as you see here, we are creating a root task. Yeah. So we are creating a root task here using a URL to an online root service. Sorry about that. So then you're generating the default root parameters. You're adding the stops to the parameters, return directions, return stops, and so on. You're building your parameters. Then somewhere in here you are solving a route to get a route result. So basically after this, once you create a route result, then here we are just creating a route graphic, and the graphic that we saw, we are creating for the route geometry. Here we are starting the navigation. Let's go into this function. So in this function, basically you are setting up a route tracker using the route result and the index of the desired route to take. So on so as you see here, you're calling the track location async on the route tracker, basically to track the location and update the tracking status. So on this track location future that we just created using this function track location async, you can call different listeners. That is, you can listen to the new voice guidance events. So it's using, so for the voice guidance, it's using the Android's text to speak the voice guidance. So here it's going to listen to that. So yeah, that's pretty much it, and that I wanted to talk about this sample. So you can go through this sample. It's publicly available on the GitHub repo, and kind of try to understand it and run it and kind of use these features in your own app. So yeah, I'm done talking about the mapping features, and I will pass on to Rama to talk about the data collection offline features.
The second theme that we are going to discuss today is data collection and the ability to work offline. The key feature in runtime is the ability to work with services in a connected scenarios, as well as the ability to take them offline. And when you're working with offline scenarios, there are two patterns. The first of which is services pattern. In services pattern, you would work with web services where you have some connectivity in your office or in the field where you can take things offline, but also your field workers might be visiting places where there is no network connectivity. So they can take things offline, go to the field, work for the data collection, come back and sync them back to the service whenever the network connectivity is available. And within services pattern, there are two different workflows. One is the on-demand workflow and the other is the pre-planned workflow. In on-demand workflow, it is more user controlled, so user can define the parameters that they want to download. Whereas in a pre-planned workflow, it's more admin controlled. So the admin would choose a set of areas and pre-package them and make them available. Since pre-packaging and making them available would make the field workers' jobs easy, or it would take less bandwidth for them to download a pre-planned package than an on-demand one. And also in a pre-planned workflows, the admin can have scheduled updates to those uh, pre-packaged items that are hosted in the enterprise. And also with the services pattern, we also started supporting reference-based maps where, say for example, on your mobile device, you don't want to take the whole of the base map, but just want to take some features from your operational layers offline. Then instead of using the default base map of that particular map, you can reference it to another base map which you already have on your device, which could be like sideloaded by an admin or can come from any other source. And one other new feature that we had is the ability to choose a polygon for area of interest. Previously, it always used to be an envelope area that you had to choose. Now we are also supporting polygon area of interest. So now by choosing an polygon, you can greatly reduce the amount of base map that you have to take offline in comparison with an envelope. And the tasks that you need to use to take the maps offline is the offline map task. So you could use the methods like generate offline map and pass in offline map parameters for an on-demand scenario, or you could use the download pre-planned offline map method by passing a map area for the pre-planned workflows. So that covers the services pattern where you have some connectivity in the office, take it to the field and do the data collection and bring it back to the office and sync them back. And the second pattern and to work with the offline data is the desktop pattern where you don't have any network connectivity, but you author these mobile map packages or mobile scene packages in ArcGIS desktop and then directly sideload them onto your device. You can set an expiration date for these map or scene packages and runtime would honor them. So in this case, like you can just work with these packages without any network connectivity. So let's see some demos with the offline scenarios. So let's search the sample generate offline map, and this sample has a base map and a feature layer. We'll want to take this one offline. You click on take offline map and then you enter the and password to access the service and click login. So this starts to generate the offline map. You can see it would try to take the base map as well as the feature layer on top of it offline, and it will also set the default parameters that are required for the offline map task. Since this is an on-demand workflow, this can take some time compared to some of the other pre-planned workflows, which could be much faster. You could see it's the whole process is happening on the server, and when the server is completed, now you can see the map is taken offline. You would see the tiled image as well as the feature layers. So that's the generate offline map. Then let's see the pre-planned map area sample. So this sample again has a map which has all the pre-planned areas. So I would select city hall area and try to download this particular pre-planned map area. You can see it is downloaded and it's pretty fast. So I can go to another pre-planned map area like the village green road area and then try to download. You can see since this is pre-packaged one, it's pretty fast to download on the field. And you can have any number of areas defined for your web map where you are hosting. Next, we'll see a desktop pattern, which is opening a mobile scene package. So this particular sample requires a scene package that I already downloaded. You can see the scene package just opens very smooth. The rendering, everything just works as expected. You can clearly see the details on the buildings in this package as well. So yeah, so that's like the mobile scene package opening and runtime. So let's see some code for the samples that we just demoed. So the first one is the generate offline map. Let me get into the presentation mode. So this activity, you can see we are defining the portal item which we want to take offline, and you define the download area as a graphics overlay, and here is the code to generate the map offline. So we set a temporary path, and then here is where we set the offline parameters, the generate offline map parameters, and we pass the download area's geometry. And then we define the offline map task, and we call the method generate offline map, and we pass the offline parameters that we just defined, and also the path where we want to download the offline map. So once the job completes, when the job is done, we check for the status of the job. Once it's succeeded, you get the job.result, and from the result you get the offline map and then set the map to the map view. So it's as simple as that. So let's go out of the presentation mode and let's see the second sample that we demoed, which is the pre-planned map area workflow. So in this particular sample, you can see again we define the offline map directory, which is the temporary directory where we want to download or keep the pre-planned maps. And then we define the portal item, which is the web map, which has all the pre-planned areas defined. And it's the same task again. It's the offline map task that is constructed with the portal item. And you can see there's a method to create the pre-planned map areas. And this method, you basically get all the pre-planned map areas defined for your web map using this method, get pre-planned map areas. Once you get all the pre-planned map areas, then you can enable the download button, and once you click on the download button, this is where your pre-planned map area is downloaded. You can see the default pre-planned offline map parameters are created from the pre-planned map area that we select, and then we use the download pre-planned offline map method and pass in the offline map parameters and the directory where we want to download the map. So once again, it's the same code to add a down listener, and once the job is succeeded, you get the result, and from the result you get the offline map and set it to map view. So that's the pre-planned map area code. Let's see the mobile scene package code. And for the mobile scene package sample, we define the scene view and the scene with the base map, and then we add the elevation surface to it. And to load the mobile scene package, all we need to do is call the mobile scene package and give the path where your mobile scene package is present on the device. One thing you need to be careful in Android is you need to give permissions to read the external storage of the files that you upload to the device. So once you have the permissions, and just load the mobile scene package. Once the mobile scene package loads, you can get the scenes from the mobile scene package and set the scene to the scene view, and it's as simple as that to view the scene view from the mobile scene package. The next theme that we are going to talk about is utilities, and specifically we are going to talk about the utility networks. Utility networks is a comprehensive framework within ArcGIS for modeling utility systems such as electric, gas, water, wastewater, or telecommunications. In runtime, you can build applications that can actually visualize your network assets, discover how these features are connected to each other. You can also trace how the resources such as gas, water, and electricity flow through your network. You can perform an upstream trace to examine the assets against the flow of the resource, or perform a downstream trace to see the assets following the flow of the resource, or you can just perform a connected trace just to validate that the features are connected to each other or not. Let's actually see how the utility networks work through some sample applications. So let's open the utility network, trace utility network sample. You can see the utility network is loaded. So I want to add a starting location, and I would select an high voltage terminal. I can perform a connected trace on it, which should give me all the connected assets results. And then I can perform a downstream trace on it, which should give me the flow of the net resource in the downstream direction. And I also can do an upstream trace, which should take me to the source controller of the subnetwork, so which should be this particular utility element. Let's see the sample code for utility network tracing. So this activity defines the set of starting locations or barriers that you want to add, and there are the operational layers that are added to it, are the electrical distribution feature layer and the electrical device feature layer, and they are added as operational layers to the map. And this is where you load the utility network, and you can see when we identify the nearest utility element where we click on the map, we get to choose the type of the utility element and create the utility element here based on the type. In this case, it was a junction. And once the utility element is created, this is the function that does the tracing part. You can see all the trace parameters are defined here, and the starting locations are passed to it, and also the barriers are added, and the trace configuration is set. Once and utility network.traceAsync is the method that you need to call to perform a trace and pass in the trace parameters. And once the trace is complete, you get the features written, and you can just select the features and display it on the map. With that, I'll pass it on to Priyanka for the next theme, 3D and augmented reality. Over to you, Priyanka.
I will go over some 3D capabilities and some AR capabilities in our samples app. So 3D and augmented reality. So it helps you display scenes in augmented reality, and ArcGIS Runtime provides support of augmented reality through AR Toolkit. We spoke about the toolkit dependency that can be added in modules build.gradle file, so as to use the AR capabilities within your app. As you can see here, the AR experience can be thought of in terms of three common patterns. Those are the tabletop, flyover, and world scale pattern. The runtime supports all three, and we will try to understand what the flyover, tabletop, and world scale pattern is. So as you see here, the flyover AR is a kind of AR scenario that allows you to explore a scene using your device as a window into the virtual world. And a typical flyover AR scenario will start with the scene's virtual camera positioned over an area of interest. The tabletop AR is kind of an AR scenario where the scene content is anchored to a physical device as if it were a 3D printed model, and you can walk around the tabletop and view the scene from different angles. The world scale kind of an AR scenario where scene content is rendered exactly where it would be in the physical world. It is used in scenario ranging from viewing hidden infrastructure to displaying waypoints for navigation. So moving on, I would like to demo some apps which showcases 3D in and AR in our ArcGIS runtime. So I have an emulator open here, and we will go through the first one, which is the line of sight geo element. So that kind of showcases some 3D capabilities. So this is using analysis overlay on scene view. So basically to tell us when a taxi is moving around the block in NY is visible from a certain place on the Empire State Building. This is all happening in real time. As you see here, the line will be green until it is obstructed, in which case it will become red. So you'll see the taxi which is moving around the block, and yeah, we'll see the red line here when it finds an obstruction. So let's look at the code within the sample viewer app, which we downloaded from the Play Store. Well, you can view it there, which is here, but I am going to view it in Android Studio. So here we are using a scene, ArcGIS scene, as you see here, and which is basically holding our data. The scene view is showing and navigating that data, and so you set the scene to the scene view. Here you add the base surface for elevation data, and this elevation data is basically 3D dimensional, and that's underneath those building layers. The graphic overlay here is basically holding the taxi graphic, which is rendered with the simple renderer here. And we got the observation point here, which we are moving up and down the Empire State Building. So the on progress changed listener, which is basically taking in the slide bar to update the position of the point. And the model scene symbol here is the graphic. It's used to actually, it's a taxi symbol graphic, and it's used for rendering and holding it. So the analysis overlay that we created here is applied directly to the scene view, and this is the overlay which actually holds the line of sight, the green part that we saw. And it's the green line that we saw, it's basically the geo element line of sight. It's a very powerful app doing the line of sight tasks. So you can go over this app. It's publicly available on our GitHub and also on the sample viewer. So let's move on to the next app that I would like to show under analysis itself, which is also a 3D capability view shed location. So here it is. So this is also using the same analysis overlay within a scene view that we spoke about, and the ArcGIS scene layer helps render all the buildings that you see here, so the ones that just loaded. As you can see in real time, we can get a view shed from a particular point, like this. And also you can try out the different features here below to do all sorts of other things, like you change the pitch, you change the horizontal angle, change the vertical angle of the view shed, the minimum distance, and the maximum distance. So this way it's viewable better. Yeah. So this is the view shed location. Let's go over the code of the view shed location, which I have opened it in Android Studio. So I would like to skip the previous part, which is similar to what we discussed earlier, of how about a scene view, and the analysis overlay. We would jump onto the code that's required to change the parameters of the view shed, like set heading, set pitch, set horizontal angle, set vertical angle, set minimum distance, set maximum distance. So as you can see, you can have all these analytical capabilities in your app quite easily. So moving on to another demo that I wanted to show is of AR, but I haven't, we would rather not play AR in emulator because it would not load quite correctly. So I had already recorded the AR video. So you would find the AR demo that I'm showing, which of display scene in tabletop. It's under the augmented reality, which is here. So let's see this. All right. So here we are using the AR to pin a scene to a table or a desk for easy exploration. As you can see, the video is not that great because I recorded over Visor, but here I am trying to we are actually trying to find a plane. The plane gets detected by AR core, and this is the camera that was used to detect the plane. Well, I was single tapping it for the plane to be detected by AR core. It takes a bit of a time for the plane to be detected. Now I'm panning around the scene and zooming in, zooming out. The scene is not quite greatly visible right now because it's a video, but it's quite visible and clearly seen on your device. So also note, the Google Play services for AR must be installed to run this app. So these tabletop scenes allow you to use your device to interact with scenes as if they were 3D printed models sitting on your desk, and it could be used to virtually explore a proposed development without the need of a physical model. So let's try to go over the code behind this. Okay, so here we are setting up the AR view to use the AR core and tracking. So as you see, I was single touching on the scene for the plane to be detected. So that is identified by AR core. And so on tap, you basically set the initial transformation matrix, which loads the scene that we saw earlier in the video. So listen for a tap from the user, then we are using this set initial transformation matrix here on the screen point, which basically allows you to place the scene. Then you create and display the scene. So this function is called here load scene from package, so as to allow you to look at the content from below. Set the base surface navigation constraint to none. So that's what this does. And over here we are updating the translation factor and origin camera. What that means, it's setting the translation factor so that the user can view the entire scene by moving the device around it. The translation factor defines how far the virtual camera moves when the physical camera moves. So that's what it does. So this is the code behind the AR display scene and tabletop AR. You can very well go through this and try to play around the AR capabilities in our app. So that's about it for me, and I will pass on to Rama to go over what's coming in ArcGIS Runtime for Android. Thank you.
So we have seen different application themes discussed so far, and again, these themes are not a limited set of themes. You can always create your own custom theme, mix different functionality, and create your own application based on the needs of your organization. So let's move on to see what's coming in the Runtime SDK for Android. So we will be replacing the GL surface view, which we used so far to render the OpenGL content. We'll be replacing it with the texture view, mainly because texture views should be a better and a convenient way to embed maps into your list views or add animations to them. So we will be working to replace the GL surface view with the texture view. There's also support for arcade feature sets that's coming in the future. So arcade feature sets are something that you can configure in your web map as a pop-up expression, and the pop-up expressions can contain feature sets. Now we will honor them in the runtime as well. We'll also be allowing online services to be packaged in your mobile or scene packages. As you have seen in the previous slides, that mobile scene or map packages kind of exclusively work in the offline environment or a disconnected environment. By allowing online services into it, you can mix and match the offline content with some online services. And also we will be doing enhancements to the utility network capabilities that we already have. So that's something you can watch out for. And there are many more features that are going to come to the Runtime SDK and in Android. So stay tuned to the developers.arcgis.com. So we will update anything that would be released. We'll put up a release notes there. So let's summarize what we learned today in this session. We talked about introduction on how to getting started with the SDK. We talked about the developer patterns that are used in our SDK. We also gave you a functional overview of the SDK. And then we talked about some of the application themes that your application can fit into. And then finally we saw some of the features that are coming in the future releases. So with that, we'll conclude the session, and thank you very much.